Nithin and welcome back to PSLE Science, and today I'll be going through forces. So let's get started. Okay, for the first segment of this video, I'm going to go through what is a force. Okay, so what is a force? A force is a push or a pull. Okay, a push or a pull exerted on an object with mass. Okay, a push. So it could be like pushing a box. It could also be pulling a box. Okay, so on an object, so the object is basically the box over here with mass. What is mass? Can you remember? Mass is basically the amount of matter an object has. Okay, while forces are invisible, so that means that we can't see them, the effects of forces, so whatever forces does, so what forces can do, so the effects of forces is basically what forces can do, are visible to us. So basically allowing us to feel or to see the effects of forces. Okay, there are three characteristics of a force. Okay, one, the type of a force. So we need to know the type of a force. So basically that's gravitational force, frictional force, or we could say friction, magnetic force of attraction and repulsion, and lastly elastic spring force. Okay, so there are four types of forces. Okay, next, the size of force. So basically the larger the size of the force, okay, so the larger the size of the force acting on the ball is in the same direction of motion of the ball, okay, the faster the ball moves. Okay, so imagine we have a ball here and it is actually moving. Okay, so it is moving, and when we apply a force, so basically if I push the ball in the same direction of movement as the ball will actually go faster, so it actually increases speed. Okay, for the direction, okay, the third characteristic is the direction. The direction of the resultant force. Okay, the resultant force is basically if we have two forces here, one force pulling here and another force pulling here, the bigger force will actually overcome. So if we have 20 newtons of force over here and 10 newtons of force over here, the resultant force is basically 20 minus 10, which is 10 newtons. Okay, if you don't know, newtons is basically the SI unit for forces. Okay, so the direction of the resultant force determines the direction of the object moving. So basically the larger number basically moves. So if we are going to ask, does it move this side or this side, actually moves in this side, because this side over here actually has a greater force than this side, thus it actually overcomes this force over here. Okay, and thus this force will overcome this force and move this direction. Okay, so I hope you understood that. So there's basically two types. One is balanced forces and another is an unbalanced force. So the balanced forces is basically like 10 newtons here and 10 newtons here. So this means that both of them have equal forces applied on the rope, and thus nobody is going to overcome each other. So this one, there's two people here. Okay, so it's 20 newtons and there's just one person here, and this is just 10 newtons. Thus these two people will actually pull this person over the line of tug of war. Okay, so you need to know that. So there's two types. Okay, remember, balanced forces and unbalanced force. Okay, so now let's move on. Okay, for segment number 2 of this video, I'll be going through the 6 effects of forces. Okay, so what are the 6 effects of forces? Okay, so these are the 6 effects in a pictorial form. Okay, so the first one, cause a stationary object to start moving. Stationary object to start moving. It's like this image over here. So this girl actually caused this scooter to start moving by pushing on the ground. Okay, next, increase the speed of a moving object. Okay, so basically he pushed his foot on the ground, causing the skateboard to actually increase in speed. Okay, so decrease the speed of a moving object. Okay, so usually when he's walking, he's actually quite fast, but he's carrying a heavy load, thus is making him move slower because he needs to carry the heavy load. Okay, next we actually have stopping a moving object. So basically this girl over here, when she was walking with a suitcase, she just stopped walking, and thus her suitcase also stopped it. Okay, next, change the direction of the movement. Okay, change in direction over here, the football. So if the football was actually moving in this direction, the boy came this way and he kicked it. Okay, so imagine this is his leg. Okay, so he actually kicked the ball this direction. So that's a change in direction. Okay, and lastly we have a change in shape of an object. Okay, so this is change in shape. So basically we can like fold an object, we can stretch an object. These are all changes in shape of an object. Okay, so I hope you understood that. Now let's move on. So you need to know these 6 effects of forces. Okay, so let's move on. Okay, for the third segment of this video, I'll be going through the 2 important key phrases. Okay, so there are 2 important key phrases that we need to know. So 1 being acting on, and 2 being greater than, smaller than, or equal to. So we use this when we are answering forces question. So this is for forces. Okay, next let me show you an example on how to use these 2 phrases. Okay, so we have a question over here. So magnetic force of attraction, gravitational force. So basically we need to explain this thing. Okay, so the magnet is actually pulling the paperclip up, but the gravitational force is pulling it down at the same time. But the magnetic force acting on is actually greater than the gravitational force acting on the paperclip, and thus the paperclip actually gets attracted to the magnet, but there's still space below. Okay, so let's use acting on and greater than, smaller than, and equal to answer this question. So gravitational force acting on the paperclip downwards, so it's basically this force over here acting on the paperclip downwards. So acting on. Okay, so we have used the word acting on over here. Next, magnetic force of attraction is acting on the paperclip upwards. Okay, so it's acting on the paperclip upwards, but we don't know whether or not which one is stronger or less strong, right? So we are going to use greater than, smaller than, or equal to in order to find this. So the magnetic force of attraction acting on the paperclip is greater than. Okay, we are using the greater than. The gravitational force acting on the paperclip, causing the paperclip to move upwards. Okay, since the magnetic force of attraction is greater than gravitational force, the paperclip actually gets attracted to the magnet, and thus it moves upwards. Okay, so I hope you understood that. Now let's move on. Okay, so for the fourth segment of this video, I'll be going through gravitational force. Okay, so let's take a look at it. Okay, this is gravitational force. So gravitational force is actually a non-contact force because the force doesn't actually have any contact with the object. So gravitational force so if we have an apple over here on an apple tree, okay, when the apple is ripe, it'll actually fall down right onto the ground. So this is actually the gravitational force. The gravitational force has no contact with the object itself. Okay, so let's take a look at it. Okay, gravitational force is the pulling force exerted downwards towards the earth. Okay, so let me highlight that. Is the pulling force exerted downwards towards the earth by the earth on all objects that have mass at all times. So if an object does not have any mass, there's no gravitational force acting on it. So gravitational force acting on an object with mass causes it to have weight. Okay, so mass and weight are actually two different things. So at the start of the video, I told you guys that mass is actually the amount of matter, right? An object has. But weight is basically gravitational force acting on an object with mass. Okay, so it's GF acting on object with mass. So this causes weight. So you need to know this. You need to know the difference clearly. Okay, next. So we need to know the two factors affecting gravitational force. So one being mass of the object. So let's take a look at it. So basically, the greater the mass of the object, the greater the amount of gravitational force acting on it. Okay, so if you have a greater mass, you have a greater gravitational force acting on you. Greater mass, greater amount of gravitational force acting on the object. Okay, so basically let's have an example over here. So if we have person 1, okay, and we have a person 2 over here, so this is his child. So this is the dad and this is the child. Okay, so the child basically has a mass of 25 kg. Okay, and the dad has a mass of let's say 70 kg. So the dad actually has more gravitational force acting on him than the child. Okay, so you need to know that. Next, let's take a look at the next factor affecting gravitational force, which is basically the location of the object. And in this case, we are looking at the earth and the moon. Okay, so these are the only two things that they might test in PSLE. Okay, so the earth and the moon. So the moon's gravity is actually less than the earth's gravity. The moon's gravity is 1/6 of the earth's gravity. So basically, moon over earth is equal to 1/6. Okay, so this is for gravity. Okay, next, the smaller the planet's size and mass, okay, the smaller the gravitational force acting on this object. So basically, if we have a person, if we have an astronaut on the moon and we have an astronaut in the earth, okay, so the earth, okay, sorry, so if we have an astronaut in the moon and an astronaut in the Earth, basically the Earth is bigger, right? So this astronaut will actually have more weight, in Earth, okay, than the moon. So basically there's more gravitational force acting on this person than this person on the moon, okay. Next, the greater the distance of the object from the Earth or moon, the smaller the gravitational force acting on the object. Okay, so the greater the distance of the object from Earth or from the moon, the smaller the gravitational force acting on the object. So if a person is really far away from the Earth, okay, so this is quite far, okay, so there's a smaller gravitational force acting on the person. And if a person, imagine this is the moon as well, the person is further away from the moon, there's lesser gravitational force acting on the person, okay. So I hope you understood that. Now let's move on, okay. Okay, for the fifth segment of this video, I'll be going through mass and weight are not the same. So I told you slightly in the previous segment about mass and weight, and that they are not the same. So let me go through in slightly more depth, okay? Okay, mass and weight are not the same. Okay, so this is basically a thing for mass, okay? Mass. So an astronaut on Earth has mass, okay? Thus, the gravitational force acting on the astronaut causes him to have weight, like I said. Okay? So, remember, mass is basically the amount of matter in object. Okay? And weight is basically gravitational force acting on an object. So weight is basically GF, gravitational force acting on an object with mass. Okay, so the weight of the astronaut causes him to fall back to the ground when he jumps upwards. Okay, so this statement clearly shows the difference between mass and weight, right? Okay, we have another statement. An astronaut in outer space has mass, okay? However, since there is no gravitational force acting on him, the astronaut will not have any weight, okay? So this basically allows the astronaut to float in outer space. Okay, so astronaut still has mass, okay? Okay, sorry. So the astronaut still has mass in outer space, okay? But since there is no gravitational force acting on him, he will not have any weight, and thus he will float in outer space. Okay? So I hope you understood that. Okay, so now let's take a look at the definitions of mass and weight and unit of measurement and the relationship that they have. So mass, the definition is basically the mass of an object represents the amount of matter the object has. So I'm stressing this a lot. The amount of matter an object has. Okay, the weight of an object represents the amount of gravitational force acting on it due to its mass. Okay, so you should know this by now. I've explained it several times already. So the unit of measurement and the method of measurement for mass is basically, the unit of measurement is basically kilograms or grams, and mass, we measure it using a lever balance. Okay, and weight, the unit of measurement is basically Newton, like I said before, and we use a spring balance in order to measure weight. Okay, so now let's take a look at the relationship. Okay, so what is the relationship? So on Earth, if a person on Earth, if something is 1 kg, which is basically approximately 10 newtons. So this is basically an approximation, okay? Approximately 10 newtons in Earth, and 60 kg is 600 newtons, okay? So 60 kg will be 600 newtons, right? If 1 kg is equal to 10 newtons, 60 kg should be equal to 600 newtons, right? So a person with a mass of 60 kg on Earth would have a gravitational force of 600 newtons acting on his body, okay? So on the moon is totally different. Since the moon is only 1/6, right? We basically take 1/6 times 10, which will give us 1.6 newtons. So this is basically an approx as well. Okay, so the 60 kg person will actually have 96 newtons acting on him. So a person with a mass of 60 kg on the moon would have a gravitational force of 96 newtons acting on his body, okay? So this is basically the difference and relationship between the mass and weight, okay? So I hope you understood that. Now let's move on to the next segment. Okay, so for the sixth segment of this video, I'll be going through gravitational force versus gravitational potential energy. So remember, we have learned gravitational potential energy in my previous video on energy, right? So now we are just going to take a comparison of gravitational force and gravitational potential energy and see what are the differences, okay? Okay, so this is basically gravitational force versus gravitational potential energy, okay? So gravitational force depends on only the mass of the object, okay? And we are not going to take into consideration the location of the object, okay? Because when we are testing, we are gonna show that they are found in the same location. So when we are testing gravitational potential energy and gravitational force, we are just going to make it as they are in Earth, okay? So gravitational force depends on only the mass of the object in this case, and gravitational potential energy depends on both the mass of the object and the height of the object above ground. So the mass of the object, so the greater the mass of the object, the more gravitational potential energy it has, and the higher the object above the ground, the more gravitational potential energy it has. And for gravitational force, the greater the mass of the object, the greater the gravitational force acting on the object, okay? So this is basically the difference. So I hope you understood that. Now let's move on. Okay, for the seventh segment of this video, I'll be going through frictional force or friction, okay? So frictional force or friction. So friction actually is a contact force. Okay, let me show you an example. So imagine a box, okay, sliding down a ramp. Okay, sorry. So let me draw it properly. So imagine if this is a ramp, okay? Okay? And we have a box over here. The box sliding down the ramp, so it has kinetic energy here, right? You should know from my previous video, kinetic energy. So it's going down the ramp, right? But there's an opposing force acting on the object, which is basically friction. So if we increase the lamp strength, right? Basically, and I'm gonna make the ramp straight. So when the ramp goes down, the object will actually lose some kinetic energy because of the friction, okay? So this friction is actually turning the kinetic energy into heat and sound energy, and thus the object actually loses kinetic energy and it comes slower and comes to a stop, okay? Because it lost all its kinetic energy when it comes to a stop, okay? So you need to know that. So this is just an mere example for you to understand about friction, that it is an opposing force and it is a contact force because is basically the rubbing of two surfaces. Okay, so basically when we are explaining, we say the friction between the box and the ramp. Yeah, so we need to say that. Okay, so frictional force of friction is the result of two rubbing surfaces. Okay, so like I said just now, rubbing surfaces with each other, friction is always acting in the opposite direction as the direction of motion. So this is basically an opposing force. Okay, the amount of friction between an object and the ground does not depend on the surface area of the object in contact with the ground. So many people think that the larger the surface area, the more friction it has, but actually that is not true, because friction is just an opposing force. Okay, so let me show you the correct factors affecting friction. So the two factors affecting frictional force is basically the mass of the object, which is basically the first factor affecting frictional force. So let's take a look at it. The greater the mass of the object, the greater the amount of friction between the object and the surface. Okay, so let me just highlight in a compact manner. So basically when there's a greater mass, there is a greater amount of friction between the object and the surface. Okay, so the surface texture of the object is also in consideration. So basically, the smoother the surface of the object, the smaller the amount of friction between the object and the surface. So this basically means that if an object is basically smooth, it means that there is less friction. Okay, and if an object is rough, like its texture is rough, it means that it has more friction. Okay, so I hope you understood that. Now let's move on, and do remember, the amount of friction does not depend on the surface area. Okay, because basically the surface area, right? So we can have a very large box over here and a very small box over here, but this small box maybe weighs 60 kg. Okay, and this big box only weighs about 10 kg. Okay, but since the surface area does not affect, right, basically this 60 kg box actually has more friction than the 10 kg box. Okay, so I hope you understood that. Now let's move on. Okay, so for segment number 8 of this video, I'll be going through friction and the exception of air and water resistance. Okay, so this is the only exception, basically air and water resistance. So let's take a look at it. So air and water resistance only depends on the surface area of the object. So this is the exception. Okay, so this is where friction actually depends on surface area of the object. So air resistance is basically, resistance basically means like friction. Okay, so this is the only exception where we have the surface area of the object depending for the amount of friction between the air and the object. Okay, so let's take a look at the example of air resistance and water resistance. Okay, so paper B over here, paper B is has a larger surface area than paper A, right? So paper B takes a longer time to fall to the ground as it has a larger exposed surface area in contact with the surrounding air. Okay, remember when you're comparing a surface with air, right, you always need to talk about larger exposed surface area in contact with the surrounding air. So this phrase is really important. It's very applicable to all, for every time you explain air resistance. Okay, causing a greater amount of air resistance to act upwards on the paper. So you see this whole highlighted part, this is a very good part, and also a longer time. So all of the highlighted parts are very important when you're explaining with air resistance, okay? So I hope you understood that. So paper A does not have a larger surface area than paper B, because as you can see, paper B has this much, while paper A only has this much. Okay? And it's basically in contact with the air, okay? So paper A actually should have this much only. Okay? While paper B has this much on the below surface. Okay? Now let's move on to water resistance. So water resistance. So there's one thing called A and another thing called B. Okay, A, this is A from the front view. So A is a smaller circle than B, okay? And from the side view, basically this is A, okay? And this is B. So do you realize something? That A has a more streamlined, right? It's more streamlined because even the front of it, okay, even the front of it is actually a smaller surface area compared to B. So object A actually travels faster through water than object B, okay? So travels faster through water than object B, as object A actually has a smaller surface area in contact with the water from the front view as well, causing the smaller amount of water resistance to act on the object. So same thing. This whole phrasing is really important, okay? Whatever I've highlighted over here is really important. Okay, so just remember, and streamline, this word is also really important. You can use our streamline over here as well. Okay, you can use streamline in your answer. It will make it much better as well. Okay, so let's move on now. Okay, so for section for segment 9, I'm going to take a look at ways to reduce friction. Okay, so what are the ways to reduce friction? So number 1, we can apply lubricants between two surfaces to make two surfaces smoother. So lubricants basically makes the two surfaces smoother. So lubricants like soap, oil, and even water will make the two surfaces smoother. Okay. Next, spreading powder on surfaces to fill up the small gaps found on them, causing the surfaces to become smoother. Okay, you know when you apply powder on a surface, right, it actually becomes really smooth because, and you guys do not understand, because the only reason it becomes smoother is because it fills up the small gaps found on them. Okay. Next, using wheels and ball bearings allows the contacting surface to roll instead of dragging or sliding over each other, like this. So this is basically a fidget spinner. There's ball bearings inside. If you take out the cap, you can actually see the ball bearings. And this box, he's sliding it up a ramp, right? But instead of doing that, he can just use a trolley with wheels in order to bring it up easily. Okay? So ball bearings and wheels actually reduce friction. Okay? So next we have having a streamlined body shape helps to reduce water resistance or air resistance. Okay, so basically over here the fish over here, the shark, basically has a streamlined body shape, and thus it can move through water really fast. Okay, and because it reduces water resistance. And the bird over here basically has a streamlined body shape when it's flying. Okay, and this actually reduces air resistance. Okay, and thus the bird can actually fly much faster. Okay, and this diver is making herself into a position so that she can have a streamlined body shape in order to move faster through the water. Okay, and the cyclist is also crouching. Okay, the cyclist is crouching on the cycle in order to have a streamlined body shape in order in order for the air to actually flow like this. So it's actually trying to have a aerodynamic shape, okay? Like the aeroplane. The aeroplane has a streamline and aerodynamic shape. So basically the air goes through like this, okay? So this is basically an aerodynamic shape. So let's see that. So basically the air will go over and under, okay? So this is an aerodynamic shape, and this will actually reduce air resistance, okay? So these are the ways to reduce friction. Now let's move on. Okay, let me discuss about elastic spring force now, okay? So elastic spring force is actually a contact force, okay? So elastic spring force is a force acting on an extended or compressed elastic object to return to its original length. Okay, so elastic spring force could be on an elastic object, right? So basically a spring is the best elastic object for this, okay? So elastic spring force, we use a spring, okay? Okay, so elastic spring force is basically the force acting on an extended or compressed. Okay, so let me just highlight that. Extended or compressed elastic object to return to its original length. Okay, next. Two factors affecting elastic spring force. Basically, first one, stiffness of the object. Okay, so this is the first one, stiffness of the elastic object. So let's take a look at this. When a load of the same mass is hung on two springs, the one which extension was less will be the stiffer spring. Okay, so I've actually explained this in the energy for the springs. Okay, so basically it's the same thing. So if I have a spring over here and I have another spring, and this one has 100 grams, sorry, so this one actually has 100-gram weight, and this spring also has 100-gram weight. The one with less extension will actually be the stiffer spring. So A or B, which is a stiffer spring? A, right? Because A actually has a lesser extension than B over here. Okay, next, the extension and compression of an elastic object. So this is the second factor. So let's read. So when a load is attached to a spring, gravitational force acting on the load exerts a pull force on the spring, causing it to extend. Okay, the increase in length of the spring is also known as the extension of the spring. So basically the extension and compression of the elastic object depends on how much elastic spring force it has. So when you extend the object more, it actually has a more elastic spring force in it. Okay, so next, when a load is placed on top of a spring, the gravitational force acting on the load exerts a push force on the spring. Okay, so here is a pull force and here is a push force, okay, causing it to compress. Okay, the decrease in length of the spring is also known as the compression of the spring. So in this case, when the spring is compressed more, it actually has more elastic spring force in it. Okay, so now let's move on. Okay, so for the 11th and last segment of this video, I'll be going through magnetic force. Okay, so magnetic force is basically a non-contact force because it actually acts at a distance. Okay, so let's take a look at the two types of magnetic force. So one is the magnetic force of repulsion. So basically when light poles face each other, they repel. Okay, so the light poles of the magnets are facing each other, causing the magnets to repel. And the second type of magnetic force is basically the magnetic force of attraction. So the unlike poles of the magnets are actually facing each other and thus causing them to attract. Okay, next. Okay, next we have 3 golden rules for magnetic force. So what are the 3 golden rules that we need to know? So a magnetism acts at a distance. Acts at a distance. So we have a magnet over here. Okay, so north, south, magnetism. So imagine if I have an iron ball. Okay, so I have an iron ball over here. So this magnet is actually going to attract this magnet, this ball over here. So it actually attracts from a distance. Okay, so if it does not attract from this distance, we are going to move the magnet slightly closer, and at some distance you will attract the iron ball without actually touching the iron ball. Okay, so you attract at a distance and it will also repel at a distance. Okay, next, a magnet's magnetism passes through non-magnetic materials. Okay, so if I have a magnet over here, okay, so north, south, and this is a sheet of paper. Okay, and I have a paper clip, let's say a paper clip over here. Okay, so this paper clip actually gets attracted to the magnet through the paper. Okay, next, a magnet's magnetism attracts magnetic materials. Like I said, it attracts the iron ball, right? And for the first one, we could also talk about 2 magnets attracting each other from a distance. Okay, so yeah, so I hope you understood the 3 golden rules of the magnetic force. So now let's move on. Okay, so magnetic force. So the factors affecting the magnetic strength of a magnet. So these two are basically temporary magnets. Okay, so let me write down temporary magnets. Okay, so the first method is to by actually use stroking. Okay, so in order to increase a magnetic strength of a magnet, we need to stroke the magnet. So how do we actually do that? So let me show you. The greater the number of times the magnetic material is stroked by the magnet in one direction, so basically this direction over here, so this must be repeated. Okay, the greater the magnetic strength of the temporary magnet formed. Okay, so the greater the magnetic strength of the temporary magnet formed. Next, the greater the magnetic strength of the magnet used to stroke. Okay, so used to stroke, so this magnet, if it's really strong, the magnetic material, so stroke the magnetic material over here, the greater the magnetic strength of the temporary magnet formed. Okay, so this is one factor over here. Next, the second one, by electric method. So this is basically the greater the number of coils around the magnetic material, the greater the magnetic strength of the electromagnet formed. Okay, so you need to know this by now, because I've actually taught this in my previous videos, in my magnet video. So if you have watched that, this will be actually a really great understanding. Okay, so next, the greater the number of batteries used in the electric circuit, okay, over here, so this circuit over here, the greater the magnetic strength of the electromagnet formed. Okay, so with that, I've come to the end of this video, and I do hope you have understood my explanation for this question, this topic over here on forces. And thank you, and bye bye. I'll see you in my next video. Bye.